everyone, and thank you for joining us today. My name is Christina Bidrotna. I'm a Senior Associate in the Investments team at the Clean Energy Finance Corporation, and I primarily have a focus on the property sector. I'd also like to begin by acknowledging the traditional owners of the land on which each of us are on today. I'm speaking from Brisbane or Meanjin, and I acknowledge boundaries are contested. So I pay my respects to both the Yuggera people and the Turrbal people and their elders, past, present, and emerging. At the CEFC, we have a unique mission to accelerate investment in Australia's transition to net zero emissions. We invest to lead the market, operating with commercial rigour to address some of Australia's toughest emissions challenges. In terms of the built environment, significant progress has already been made to reduce the property sector's operational emissions. But our ability to achieve further reductions will depend on success in areas that have proven harder to abate. So those such as Scope 2 and 3 emissions, being the indirect emissions that occur in the value chain, including both upstream and downstream emissions. So in that sense, embodied carbon is the next frontier in the task to decarbonise the property sector. Now, to demonstrate the growing importance of addressing embodied carbon, I'd like to draw your attention to the two circular graphics on this slide. On the left-hand side, we see that embodied carbon in the production of building materials is responsible for 28% of emissions from the building and construction sector. Climate change policies for emission reduction strategies and factors such as the decarbonisation of electricity grids and incremental improvements in building efficiency are expected to reduce the share of operational carbon emissions compared to embodied carbon, which is a great news story, but it does mean that when we move to the next circle, we see that by 2050, embodied carbon is expected to account for almost half of total emissions from new constructions. Concrete, steel, and aluminium are considered some of the more challenging materials to decarbonise. So given the significant expected shift in breakdown between operational and embodied carbon emissions, we wanted to help quantify the challenge of cutting embodied carbon, as well as identify some of the solutions and opportunities this could create. So the report, titled Australian Buildings and Infrastructure, Opportunities for Cutting Embodied Carbon, was developed by Edge Environment for the CEFC in collaboration with the Green Building Council of Australia, the GVCA, and the Infrastructure Sustainability Council, the ISC. It draws on project data from the GVCA Green Star and the ISC Infrastructure Sustainability Rating Schemes, and that's complemented by extensive modelling and industry discussions. Sorry, I'll just move that off the screen. So for the purposes of the report, embodied carbon is described as the greenhouse gas emissions, and that's measured in carbon dioxide equivalent, that occur during the resource extraction, the transportation of resources to the manufacturer, the manufacturing process, and then the transportation of those materials to the construction site. You may notice when reading different reports, they include slightly different stages in their definition of embodied carbon, but for the purposes of this report, those 4 stages are what's captured when we speak of embodied carbon. Edge Environment estimate the embodied carbon emissions of materials used in Australia is somewhere between 30 to 50 million tonnes of CO2 equivalent per year. Now that's approximately 5 to 10% of national greenhouse gas emissions. So it really is a significant contributor to emissions across our economy. The economic value of the construction materials sector is approximately $65 billion. With demand for low embodied carbon solutions expected to rise significantly, we estimate it could result in $1 billion low carbon solutions market in the coming years. So it really is a huge opportunity. And with that in mind, the analysis for the report focused on 2 key areas. Firstly, an analysis of how recent infrastructure and building projects have reduced embodied carbon. Now that's based on data from the ISC and the GVCA. And secondly, in an Australian first, an analysis of how new projects could adopt material and design initiatives for reducing embodied carbon, as well as the cost of implementing those initiatives.
Christina, can you please, now it changes. So.
Oh, sorry. So for the recent projects, the key findings were, on average, the sustainability rated infrastructure projects assessed are achieving a 33% reduction in embodied carbon. Now that's compared to a similar design with no sustainability measures incorporated. For the building projects, the average reductions were 15%, but we do note some individual projects are achieving significantly higher emissions reductions. Now for new projects, the analysis of material and design initiatives found that cost-effective solutions are available today to substantially reduce embodied carbon. Depending on the initiatives implemented, it's possible to achieve a 5 to 18% reduction in embodied carbon, whilst also saving 0.4 to 3% in the cost of those materials. Key initiatives for cutting embodied carbon emissions whilst also saving on costs include precast concrete, low carbon concrete, and pleasingly engineered timber. The report found that the use of timber can reduce embodied carbon by up to 75% compared to the use of conventional steel and concrete. So on the back of these findings, we've just launched our $300 million timber building program. Now, this is a debt program to encourage mass timber construction across the property sector. Projects will be considered on a case-by-case basis, but should utilise low-carbon engineered wood products in large-scale construction, involve appropriately sourced and accredited materials, and achieve sound embodied carbon outcomes. Require more than $20 million in CEFC debt finance, be commercial and deliver a positive return to the CEFC, comply with our investment policies and guidelines, and it's open to Australian-based projects across all property sectors. So as well as helping achieve substantial embodied carbon savings through encouraging mass timber construction, we hope the program will also help develop local skills and experience, supply chains and delivery capabilities to catalyse even more timber-based building activity into the future. And if you'd like to know more about the timber building program, you can visit our website, which has a really handy fact sheet as well. I'll now briefly touch on some of the investments the CEFC has already made to address embodied carbon. We have a $95 million commitment to the Roe Highway Logistics Park in Western Australia. That project uses Boral's low-carbon concrete that achieves up to a 42% reduction in emissions compared with traditional concrete. So this, along with some other features, will enable the project to achieve carbon neutrality. A $75 million commitment to Fraser's property is targeting embodied carbon reductions across 2 of their industrial projects. And a $54 million debt finance commitment to Northcote Place in Melbourne is helping build sustainable townhomes featuring the Wholesome EcoPact product. Now, this is a low carbon concrete that reduces embodied carbon by 30 to 60%. If you'd like to know more about anything I've spoken about today or the timber building program specifically, feel free to reach out to myself or my colleagues, Brian Rathborne and Michael DeRusso. They are the co-leads of the property platform at the CEFC. Thank you all for listening, and I'll now hand over to Jonas from Edge Environment to touch on the more technical aspects of the report.
Pleasure to be here, everybody, and thanks, Christina, for the great intro, and Paolo as well for setting the scene. So I'll talk a little bit more around the background and the details in terms of how the report was produced. It's pretty well documented in the report, which is obviously publicly available as well, but it's always easier to kind of get a verbal kind of description of how the work was produced to some aspects, and then obviously more than happy to take any questions in this webinar or afterwards as well. But as Christina said, the frame we went in with this one was to look at opportunities to reduce that upfront embodied carbon bit in Australian buildings and infrastructure. And by the upfront embodied carbon, here we mean the raw materials, the manufacturing of construction products and materials, and the transportation to the construction site, but not looking at any carbon emissions or implications beyond that. So it's that upfront, which is a pretty tight scope. And I just want to use that as a caveat, because looking at materials, obviously it's very important around the maintenance, durability, end of life as well, specifically important for timber products, what is going to happen to the materials after the construction and end of life, for potential for reuse. So just want to frame that's the scope of this assessment. And Christine already touched on it, but there was very much industry and engagement and support throughout the process. So CEFC were a great partner to guide and instigate the development of this report and fund it. And then the Infrastructure Sustainability Council and Green Building Council of Australia provided the data, which was really good to get a view on the work that's been done over the last almost 10 years in the different areas. So for Infrastructure Sustainability Council, we got access to some projects submissions in terms of what's been done with the material calculator in the IS rating tool, and for Green Building Council of Australia, get access to the life cycle assessments of buildings that's been submitted through the Green Star project. So that was almost 200 individual LCAs that we had the opportunity to look at and analyze. And that's where we got the typical reductions in terms of embodied carbon that Christina touched on, in terms of that 5 to 15% range typical. So that's probably without pushing, because a lot of the focus to date has been on the operational aspects and the energy aspects optimization. So lots of opportunities for further improvements. And then case studies are provided. A few of those will be spoken to after my bit here. But the industry engaged a lot in terms of providing information and data. So thank you specifically to InfraBuild and you mentioned EcoPact and Holcim, what they've done, and et cetera, and timber industry and builders. So lots of good engagement and validation along the way for the study. And it is a huge opportunity, and it is a big market. It is around that 5 to 10% of Australians' greenhouse gas emissions is in this sector here. And it's a big economic opportunity as well. And this is excluding imports. So if you look at the importation of construction materials, the estimate is that there's about $10 billion of imported construction materials into the built environment here, and very limited exports from Australia. So there's a net opportunity there to look at potentially how we can build up a more of a circular economy in this space as well. And just to give an example of one project, to give the order of magnitude of opportunity. So WestConnex is an infrastructure project, obviously a 33 kilometers motorway, and just the quantity of material that goes into a development and project like that, it's 1 million cubic meters of concrete, and weigh that against the total amount of concrete produced. And in Australia, typically it's around 30 million cubic meters. So one project can make a huge difference, and 150,000 tons of steels, and overall $1 billion of material contract value. So that's just one project. So when we talk about the $1 billion market and opportunity, that's almost an understatement that it's a significant one from an economic perspective for producers and manufacturers that get on the front foot here, regardless of product and material class. So the report is quite wide-ranging and broad, but I wanted to drill down specifically on the technical aspects to provide transparency and some details around that. So the methodology that we applied in order to look at the reduction potential in individual asset classes, and also the cost implications, which I'll talk more about in a second, was essentially to look at calculate the embodied carbon emissions for a reference case building and infrastructure projects. So I'll talk a little bit more about what the building classes were that we looked at, but have that baseline of this is typical. And that's where we relied a lot on the GVCA data for Green Star in terms of providing that baseline in terms of quantities of materials and footprint. And then to look at what are the initiatives and opportunities to reduce. Obviously, that needs to relate to what are the hotspots and the material kind of areas where you can achieve those reductions. And then to quantify the emissions reduction potential for those different initiatives. And then what was quite new to this assessment, which there's not too much added on, to combine the life cycle analysis and carbon assessment with then the cost implications of that, which I'll talk more about the marginal abatement cost curve aspect in a second. And also talk about the enablers and barriers to implement a lot of these initiatives to drive that. I won't go in too much into the enablers and barriers, but that's just to indicate that that's also part of the report where you can find information about that. Now, in terms of carbon reduction potential and strategy, the most potential are, as we all know, the earlier you consider it and think about it. So in the planning stage, that's when you can have the most radical reductions. Obviously, if you think about reusing of assets and avoiding even the use of and the need for materials. So thinking more from a circular perspective, reuse and adaptive reuse, that's how you really avoid carbon reductions. And then it's on a falling scale, build less and maximize the use of existing assets, build smarter, build more efficient. But the opportunity to and potential to reduce is also reducing the further down the life cycle you come. Now, most of the analysis here is not in the early stages. It's more in the cross section between design and construction. So that's just a caveat as well, that when we talk about carbon reduction potential, it's already way down this kind of scale in terms of opportunities that we're looking at. So it's not capturing the whole overall holistic opportunity to reduce carbon in the built environment. And so this is probably conventional knowledge, but looking at the Green Star and GVCA lifecycle analysis baseline, the concrete, steel, and aluminium are the major contributors to the embodied carbon in buildings. That's no surprise. So a lot of the initiatives that we looked at were from that starting point that it's about how can we build with lower embodied carbon implications, focused a bit around the use of these materials and substitutions. So that was the initial focus, just to frame it up a bit. Now, in the initiative types, so we looked at both design and material. And in the design aspect, we looked for in the material types of concrete, timber, and steel, concrete around whether to use opportunities to use precast elements instead of in situ, high strength concrete, looking at substituting steel with engineered timber, looking at high strength steel opportunities, and in the material selection, opportunities to include additives to lower cement content, use supplementary cementous materials, which is commonplace in the concrete, obviously, industry already. Looking at carbon neutral concrete and more leading or innovative, perhaps, geopolymer concretes. Looking at carbon neutral steel, looking at steel produced from predominantly using renewable energy. And that gives an indication as well around the green hydrogen and use of hydrogen in steel making, in order of magnitude of what the reduction potential is. And same with aluminium, so sourcing of aluminium produced, powered by renewable energy. So those were the type of initiatives that we looked at predominantly. So what we did with this was we calculated the carbon reduction potential if you deploy a degree of uptake of those initiatives. So say that we use 10% uptake of, say, precast instead of in situ, 30% and 50%. So we didn't look at a complete replacement. So looking at how can we reduce structural steel with engineered timber, 10%, 30%, 50%, not completely, just to keep a conservative aspect as well, knowing that there are limitations around design in some aspects. But we looked at this, so if you think about this, this would be the opportunities in terms of carbon reduction. Think about this as the x-axis conceptually, but then the cost aspect as well. So this is a different example, but say we take the LED light upgrades. In a building in operational stage, you can reduce a certain amount of overall life cycle carbon by having more efficient lighting. What would be the cost from a carbon reduction perspective over the life by replacing and using LED lighting instead? And you would then save money over time by having more energy efficient lighting. So that would be a carbon reduction opportunity where you end up saving money from a CapEx and OpEx perspective. So we looked at all the different initiatives from this payback, if you will. How much carbon can you reduce, x-axis, and what's the cost implication of reducing carbon in that way? Now, marginal abatement cost curves are based on specific scenarios, and there's a significant degree of variation between different project locations, material suppliers, etc. So this is just a starting point. This is for the purpose of essentially providing the framework and instigating the framework to use the lens of both carbon reduction potential coupled with the cost implications of it. So we need to be very clear around when we look at the marginal abatement cost curves here, that they're just based on average and specific scenarios, and there could be significant variation between projects and circumstances. So this is from the report, looking at the office and mixed-use building. And you see the format here for the marginal abatement cost curve, and the most cost-effective opportunities and potential here is in the precast concrete and engineered timber. So engineered timber substituting structural steel in buildings. And then you see the using 30% cement substitution in concrete. There's a reduction potential in that. And it doesn't typically come with a cost premium because it's commonplace, it's common practice to use a certain degree of cement substitution. If we go to the right here and look at carbon neutral concrete and carbon neutral steel, you can obviously achieve a lot in terms of carbon reduction, but it will come with a cost premium almost certainly because there's this additional certification typically and the cost of the offsets to achieve the carbon neutral, to neutralize the emissions. So typically that almost automatically comes with a cost premium. And then you can see the scale towards the right there with steel from renewable energy, green powered aluminium, concrete with admixtures, high strength concrete, geopolymer concrete. Great initiatives to reduce emissions. But in this analysis, in this scenario that we looked at here, they would be investment in terms of cost. So when we say implementing the 30% uptake, of the 3 cost neutral and cost negative initiatives, that alone has the potential in this scenario for this building class to reduce upfront embodied carbon emissions by 12%. So that's literally just going towards the ones that will save you money or be cost neutral. And then you can go in and look at the other opportunities further and see whether for the project specifically or with the suppliers available, there's opportunities to include more initiatives. So this is just reflecting on what we see today, pretty much that 10-15% reduction is readily available, but much more potential to uncover. And this is the same view, but for industrial buildings. And you see largely the same design and material initiatives come up with a precast concrete and engineered timber, cement substitution in concrete. And when we looked at this to pick out some of the insights here, across the project, and we can achieve a cost saving of approximately $365,000, so about 3% of the project material cost, by adopting those low carbon, cost effective initiatives. So that gives an indication around what's available now and where to look for the biggest bang for buck and where to drill into the cost implications. So hopefully this makes sense and is useful in terms of kind of a view and a framework for looking at reducing cost and embodied carbon in materials to go after that opportunity for carbon reductions. Taking a slightly different lens and looking not just on a specific project material selection specifically, but what else is possible. And this is just, think about it as order of magnitude reduction potential that could be achieved. So remember, we have about 30 to 50 million tons of carbon emitted every year that goes into construction materials and products. What if all material suppliers switch to green power today? Now that's not possible, but what if? That would be the order of magnitude of reducing the emissions by 7 million tons, so 7 megatons of carbon dioxide per year. That's from switching to renewable energy. That's the potential. What if 1 in 10 projects use the lowest carbon materials available? There's a potential of 1 to 3 million tons of carbon dioxide equivalents. Now, this is where environmental product declarations and supplier LCAs comes in about comparing. Not all products come with the same carbon footprint. There are variations because some suppliers have invested more in low carbon production facilities and supply chains. So there is variation between suppliers, and EPDs is a great way to evaluate. And there is potential by just 1 in 10 projects, look at that. I'm going to select a supplier with lower footprint. 1 in 10 projects go carbon neutral using offsets. That's 3 to 5 megatons of carbon dioxide. Top 15 material suppliers reduce emissions in line with the Paris Agreement. So that's the decarbonization towards the 1.5 degree warming target. That will then reduce between 3 to 9 million tons of carbon dioxide per year of that total 30 to 50. And we also see a lot of suppliers and producers are already signing up to this decarbonization initiative and following the science-based targets. So that's already well on its way, both in Australia and internationally. So finally, what we learned from looking at our experience, talking to industry bodies, talking to projects, we can probably sum it up into 6 different kind of key findings. One is that there are substantial emission reductions possible already, and they are happening, and we'll talk about that on the case studies in a second. And targets to reduce embodied carbon should play a key role in the sustainability vision. So again, something that we see in industry, from government and from construction firms and developers, they are starting to implement targets that covers the scope 3 emissions and the embodied as well. And as we've seen, the targets and goals should be developed in the earlier stages of the project lifecycle as well, because that's when you have the most opportunity to reduce, really, and the opportunity to find the most cost savings and benefits. And all project stakeholders have a role to play in addressing embodied carbon. It cuts across absolutely every profession, from suppliers to engineers, architects, client side, rating agencies like Green Star, etc., procurement department, etc., builders. Everyone has a role to play here, a significant role. And investment in embodied carbon reductions can reduce costs. So just provided one example, and I'm sure that the case studies will talk a little bit about the cost effectiveness as well. And this is then, we think, and what the analysis show, that going down this journey will essentially increase your competitiveness and set you on a path of a differentiator, because you're going to develop a different way to do things and learnings that's going to save you money and save you carbon in future projects as well. So that's a bit of a snapshot. I'm going to hand over to the panelists to talk about the case studies as well, and then obviously happy to take questions and follow up in the webinar or afterwards. So thank you very much, and I'll hand over to Atreo and Melissa.
Thanks, Jonas. While Atreyu is getting sorted, I'll give a little spiel about K5, or 25 King Street, as it's more commonly known. Yeah, awesome. So 25 King Street is a fun project I've had the privilege of seeing at both sides, being at Lendlease and then at Oricon, and it's being Oricon's HQ in Brisbane. Like Jonas kind of hinted, it's definitely a collaborative effort to get these kind of projects off the ground at the moment, as people are still experimenting and trying new things. So you can see the list of the project at a glance of the architects and engineers and developers involved in making this project a reality. The project targeted a number of sustainability initiatives, but it was the tenant and the developer who really joined forces in making the decision to go timber. So it is a concrete podium base and a timber 7 or 9-story building, sorry. And the majority of the embodied carbon savings is coming from the timber itself. And then it's supported by really ingenious concrete. So that's SMC replacement, so cement replacement, but also geopolymer. They tried a lot of things out on some of these projects with Lendlease to sort of see how the timber and the concrete could work together in the most efficient way. So it wasn't just about substituting one concrete for another mixed design. It was about making sure the concrete structural system was intelligent and smart and efficient in its way it was supporting the timber. So it was about making sure that the core and the podium, you know, was efficient in its own right before then substituting that material with different strengths and so forth, and mixed designs. And then also reinforcing, there was a strong focus on a recycled reinforcement approach with this project, as well as post-tensioning, which was kind of not really the structural engineer's preference, but it made a saving, so it was definitely included. And then of course in the fit out and the integrated approach of showing off the timber for what it really is, removing a material altogether in the sense of removing ceilings from the project actually resulted in a small saving. It's 1%, but it still adds up. It's one less product being used, being made, being instituted in a building. And also as that building grows and changes and adapts, which its different uses over time, it's an embodied carbon saving that can kind of be banked along the way, even though it maybe doesn't show up so holistically in the life cycle assessment. So that's just kind of the quick spiel on 25 King Street. I gave a webinar presentation last week, so happy to take questions on it, on how we did this calculation, how we came to these conclusions. But it's definitely drawing on all of the insights that Christina and Jonas have kind of hinted at that kind of came together for this project. I'll hand over the mic to Trey.
Okay, thanks everyone for joining. I'll keep this fairly brief. There is quite a lot of documentation available for this particular project. There's some existing presentations and webinars on wood solutions that sort of deep dive into the structural design and construction of this project. So I'll try to keep this fairly brief and focused more on the LCA side of things. This project, the Latrobe Uni Student Accommodation, or North and South Apartments, as it's now known, was completed in 2020. I think it's still the largest mass timber, certainly CLT project in Victoria. It's predominantly, it's a student accommodation building, 624 beds, approximately 18,000 square metre GFA. So it's quite a substantial structure in its own right. So 18,000 square metre GFA, the building has achieved 5-star Green Star certification as built. As the CEFC report speaks to, there were some quite substantial savings in the global warming potential of the building through the use of timber as compared to an earlier reference design for the project, which was in a more conventional reinforced concrete. So predominantly CLT construction, the timber was imported from Italy. That decision was largely driven by the builder and their procurement processes, cost driven, but also importantly for this project, one of the big considerations was program and the local suppliers who would have had the capability to supply this project at the time weren't able to meet the required program. So the timber was supplied from overseas. There was also a lot of concrete in the project, similar to the case study that Melissa's just referred to. We took the approach of using concrete for the substructure and a sort of concrete podium and a lot of the cores. So a lot of energy was also put into smart selection of materials and concrete mixes for those aspects, which also plays into the overall reduction of energy used in the building. The client made a decision to go for a more high performance facade, something more akin to a passive house standard, albeit they weren't targeting passive house. And so there's also quite significant savings in the operational energy for the building moving forward. So just a snapshot of the life cycle analysis for the building, and consistent with Christina's presentation earlier, we've focused on modules A1 to A4. So right from the manufacturing process through to the transport and delivery of the materials to site. I think there's quite a lot of learning still to go, I think, within the broader industry around how we account for the remaining modules, but for the time being, the focus is typically on the modules A1 to A4 or 5. So there was around a 75% reduction in the embodied energy used, or embodied carbon used for the structure. That's just the structure only, so it doesn't include all of the fit out components and non-structural elements, and of course doesn't include the operational side of the equation, which is in itself quite significant. So this probably translates to something around 15% of reduction of the total life cycle carbon for the building. And that's pretty much my presentation complete. Happy to answer any questions.
Very good. So if you would then share, Atreyu, thanks a lot. Very interesting presentation. I would now start by looking at the questions that we received from the attendees. They are ranked also by some of you in terms of their interests, but there's plenty of interesting questions. So I will start with the one from Mike Knight, and if you speaker and panelists would like to have a look as well, how does global supply of timber look over the next 30 years if we achieve objectives towards transition to timber in Australia and internationally? So that's a broad question, and I open the discussion to the panel, to Christina, Jonas. Maybe you are not timber procurement specialists. Melissa and Atreyu have been exposed to that. I have been exposed to that a lot, but honestly, I would like to hear the opinion from Christina and Jonas first, and then the rest of the panel.
I'm happy to start by confessing that I don't know.
Okay. How would you get your knowledge then if you were asked professionally by one of your clients to answer on this point?
I would go to one of our great partners in the timber industry and get their view. So I know that there are discussions that we have, for example, with one of our chairman at Edge Environment is on the managing director of New Forests, and we have discussions around this, but I'm just not qualified to give an appropriate. But I know that it's a big challenge. That's what I hear. That it's in short demand and it's short supply, and also getting the right certifications as well and kind of qualifications of the product is a challenge. I know that. But I'm not able to look 30 years down the track, unfortunately.
And Christina, unless you have an opinion that you want to share, I won't embarrass you by asking the same question.
Yeah, no, much the same. Not qualified to speak about it, but would speak to someone who knows a lot more about it than me.
Yeah, as a matter of fact, Jonas is right. There's plenty of people who are dealing with this. There's a few interesting publications. One, for instance, from University of New South Wales, which addresses specifically this point and has modeled different scenarios. We at Wood Solutions, among our stakeholders, there's all the growers. So we have exactly the amount of plantations that are existing now in Australia and how they grow. So based on our statistics, we elaborated some calculations on the safe side on how much logs, logs are grown per minute by these plantations, how much engineered wood products, CLT, glulam, LVL, can be produced if we were using all these logs, and therefore it's easy to calculate how many minutes it will take to replace the timber used in a structure like the Latrobe or the 25 King or any other which people are designing for. So refer to us, refer to other experts in the field, and there are sound studies and forecasts on how sustainably we can follow up on an increased demand. Another,
I'll just add to that, Paolo, as well.
Yep.
You know, I mean, logs is obviously an important part of that equation, but you know, the suppliers and manufacturers we speak to and builders, I often find that the limiting factor at the moment is not so much the raw material supply, it's the manufacturing capacity within the market and the transport logistics and all those sorts of things. So obviously, if you know timber continues to grow it as a mainstream material used in construction across Australia, then yes, you know, plantations will need to grow to meet that demand. But probably I would say the immediate focus needs to be around local manufacturing capacity.
Yeah, indeed. And as you know, industry invests in growing their capacity in function of the demand that they receive from the market. So growing demand will grow the investment. The CEFC will be there to help, like other traditional banks and lenders. So I think, the growth of the market is certainly a healthy one, and we'll find some answers into the actual ultimate renewable. This is what we call timber, right? So there's a couple of questions now, one from Chris Bantin and another from an anonymous attendee, which have had high ranking. If you can look at that, does the embodied carbon impact of timber incorporate consideration of the high carbon cladding materials often used to achieve the fire rating of buildings? Open to the panel.
I could probably,
yeah,
you go, Jonas. Oh, yeah, okay. Well, just in terms of the Latrobe case study, yeah, so absolutely, there's a lot of aluminium and non-combustible types of materials, glass and so on, used in facades, and they do account for a significant amount of the embodied carbon in a building. So the statistics we presented earlier were purely focused on the structure alone, and they realistically represent a pretty small percentage of the overall carbon used in the building. The structure might account for a third of the overall total life cycle carbon, the remaining 2/3 being operational. And then within that small component, the structure may only be half, and the remaining half is in things like facade and fit out, carpet, ceilings, all those sort of non-structural components. So, yeah.
Yeah, good. So this leads me to a question from Sky Dick, which I will probably first ask Melissa and Jonas to answer. And it is, what tools are people typically using in Australia to complete their life cycle analysis?
There are many. So the ones that I've had most exposure to are a lifecycle tool called Garby and a lifecycle tool called SimmerPro. They tend to be the most comprehensive and I guess popular, but there are a whole range of now freely available tools that allow people to do similar analyses. OpenLCA has shared databases with SimmerPro and Garby, although not the licensed databases you have to pay for, but the previous or older generation databases. There are a whole host of other tools that do similar things. There's also a whole host of embodied carbon calculators coming out from places like ISCA and from the iStruct group in the UK. They've released an Excel carbon calculator tool that is used primarily for structure to the same calculations. But I don't know, have I covered most of them, Jonas?
Yeah, definitely. And Green Star is offering a calculator as well for the upfront embodied carbon. But there's specific tools as well. I don't know if you mentioned eTool, Lifecycle Design, for example, is in Australia, which is focused specifically on buildings to make it easier to do lifecycle assessment of buildings. And there's also one called One-Click LCA, which is maybe not living up to the name, but it's a simplified way to do assessment of buildings as well, lifecycle assessment. But we, for example, from a practitioner's point of view, I do use SimmerPro because and eTool as well, but mostly SimmerPro because it kind of gives more flexibility, I suppose, and adaptability. But that's quite a lot of it.
Yeah, look, probably the most important thing to my knowledge is that irrespectively of the tool that you're using, the input data needs to be of good quality. Your end result is as good as your input data are. And therefore, there is a focus now of using environmental product declarations, which are compatible to each other, so developed with the same set of rules, let's say. Let me make it a little bit simple, so that they are really comparable. Otherwise, when you want to talk about apple for apples, if you use data sets which are not derived from the same approach, it may be misleading a little bit. Another interesting question from an anonymous attendee on this point is, why are timber products embodied carbon factors sometimes positive, like in Epic Green Star, and sometimes negative? Up to you, Jonas, maybe?
Yep, sure, I can talk to that. So building on your point there, Paolo, in terms of the data sources, so very much for these particular purposes, very much a proponent of using industry data as much as possible. So rely on environmental product declarations and process-based life cycle assessment, as it's called, because that's what the industry uses globally. And that's the way this kind of comes together, as you say, because it's aligned to the same standards. So EPDs would absolutely be the go-to, and process-based LCA, that's what we used for the CEFC study as well. That's the most robust. There's other purposes for using what's called sometimes hybrid and input-output, but for these purposes, you should definitely use EPDs and process-based LCA, in my opinion. The numbers there, so there's, if you open up an EPD, you will see that there's a carbon footprint associated with the biogenic carbon, so carbon that's absorbed from the atmosphere into the trees as they grow, and one which is associated with the emissions from combustion of fuels and other emission sources. And it depends on if you combine those and look at those individually, we can get negative numbers or positive numbers. Now, just to reflect the way we did it in the CFC study, is that was only looking at the upfront embodied carbon, and we don't know what the end-of-life fate is of the steel and concrete and timber. We didn't actually account for the carbon that's sequestered, so we didn't use any negative numbers. We only used the emissions associated with the logging and transport and processing and distribution to site. But when you see negative numbers, that's almost certainly accounting for the actual carbon dioxide that's been stored in the wood products and taking that into account. So that's why you see the difference, if that makes sense.
Yeah, good. So you answered also a couple of questions which are related to biogenic carbon, etc. I have now a question for Christina, if you don't mind. Nobody asked it, but I really feel like hearing her opinion about this. So the CEFC has committed a large sum, and more than the money, it has committed its support to developers who want to choose using timber in the coming months, right? What will success look like for your timber building program?
Very good question. Yeah, so we've got, I guess, $300 million of debt finance that we're allocating towards supporting these types of projects. I think success would be over the next few years having deployed a significant amount of that money, but not just, I guess, supporting the projects that we're actually investing in, but building the capability in the market. I guess by supporting demand, we're hoping that supply will follow, particularly domestically, but also the skills. So I guess we've seen some proponents having a traditional concrete steel structure as well as a timber design. And then when push comes to shove, the timber design kind of falls away because it's difficult. They haven't done it before. It's not what they used to. People tend to kind of stick with what they're comfortable with. And we really want to kind of be that point of difference that locks in the timber design when it's right, when it's the right material for the right structure. We want to make sure that people are deciding to go with the timber. And we think that by driving that demand, hopefully the supply will follow, and the skills and the experience just by having that exposure and building up their confidence with those designs. So yeah, hopefully it's broader than just the direct investments we do, but we want to see that shift, I guess, across the whole construction sector.
Yeah, excellent. Any comments from Melissa, Trey, or Jonas on this? What would you suggest to the CEFC in order to evaluate the success of their program?
Oh, that one I'm going to pause on for a second. I guess I'd only reiterate Christina's comment on supporting the industry through the design process. Having been part of a few timber designs, it is a more challenging design process. It's kind of that traditional project management thing that says if you spend that little bit extra time in design, you end up with a better project. Timber almost forces you to do that with the manufacturing process in order to build with it. but doing so forces you to make a lot of upfront decisions. And I think as an industry, we're not quite comfortable with that just yet. And it's great to see the support of knowing that we're going to kind of have to make a few mistakes and fail and learn in order to get comfortable with that. And there's big organizations supporting that. So I guess that doesn't answer your question, Paolo, but it's definitely a comment I wanted to add in there.
Yeah, look, I can only agree. Yes, we need more timber, but especially we need more projects in which timber is used to its best, together with other material in an optimized mix. We want good projects with timber, not just more timber, without quality.
Yeah, definitely support that, the right materials for the right projects, not just timber for the sake of it.
There is an interesting question which has many likes, 6 likes, on how does precast concrete help carbon abatement? Is this smaller volume of concrete by using high strength concrete or something else? Atreyu, maybe you are the design specialist here.
It's a pretty open-ended question. I'd like to hear from Jonas actually on that. Yeah, my structural engineer sort of hat on tells me maybe it's not quite as different as in situ concrete, but Jonas might have some more insight.
Yeah, so the way we modeled this just high level was so the overall this is a relatively high level study that we did to get the order of magnitude. But when looking at precast concrete, we looked at those optimizations in terms of efficiencies in producing precast and kind of prefabricated components, which includes opportunities to there would be less waste, for example, in the pouring of the concrete on site. There would be other opportunities to. So in essence, to sort of carbon reduction as well. When we look at that, it wasn't that mind blowing in terms of the potential. It's more that the cost effectiveness of it was really good because of those prefabricated kind of elements and optimization. So that's what really, like, every ton that you save in carbon dioxide there is you can do it at a very low cost essentially, or the cost save. So that's really what comes through. It's kind of separating the X from the Y axis, if that makes sense. So not a huge potential, but when you can use it for those efficiency purposes, it's really cost effective.
I think I would support your comment, Jonas, in also saying that extending beyond, the A1 to A4 boundary, precast also offers a lot of opportunities in the construction component of the life cycle. It gives constructors ability to kind of swap and change and do things offsite in a modular kind of aspect, which when you start to reduce your construction constraints and pull things out of your critical path, you start to get a lot of benefits. And some of those are also carbon abatement, not just in the material itself, but in the getting to site and the on-site time and the equipment on site as well.
Yeah, indeed. And look, there's plenty of questions that we still haven't answered, but we reached 12 p.m. So still there's a lot of people online, almost 300 attendees still online. So if you don't mind, we can go on for another couple of minutes. I would love to hear your question to each other, because having a panel like this, it doesn't happen every day. So any question from within the panel, that would be interesting. No? All shy? I cannot imagine that.
I'm very curious about that kind of that follow-on from that comment around the sensible use and the future of hybrid construction. Where is that, Atreyu and Melissa, where you see this going in terms of that's going to get away from the trenches of steel versus concrete and so on, and think more holistically? You see that's the where this is heading?
I'm seeing it at the moment. I'm seeing a lot of developers and builders having the conversation. They're probably not ready to make the jump into construction yet, the cost is still a little bit prohibitive and they're a bit scared of the risk for some of their more major projects. But we're definitely seeing a lot of investigation in it with the new green buildings tool as well, with the climate positive approach, where I've seen hybrid structures, I've seen timber on top, I've seen all sorts of kind of design trials all the way through to kind of that decision cost planning point of going, does this actually work out to get on site? And at the moment, it's just not making it there for a whole range of reasons, usually not to do with the material or the structure itself.
Yeah, I'd agree with that. The barriers for the adoption of timber still seem to be around procurement and price, whether that's perceived or real. And so we are finding that, the conversation's increasingly steering towards hybrid type solutions. And that's what, we think as kind of purists as structural engineers, it's about using the right material for the right job. And we've seen, I think, a lot of examples where there's perhaps been a more dogmatic approach to the use of timber, and it's not always, used in the most sensible way. So I think the pendulum's starting to swing back to a more of a balanced approach towards that, and perhaps some of the more established institutional type clients are now getting on board with that kind of thinking. So yeah, a lot of projects in the planning phases, as Melissa says. I think the last couple of years we've sort of saw a bit of a slowdown of interest in timber, just concern around market volatility, but I think we're starting to see that people poke their head above the parapet again and some more interest. So yeah.
Well, and to wrap it up, I would like to say that I really thank all of you. I thank the organizations that are behind you, your colleagues who made it possible for you to elaborate this very interesting study that was presented and to come to the decision of the CEFC board to support the construction industry, not just the timber industry, with such a statement and commitment, which will make a difference indeed. I'm really curious to see how much and in what terms, but I am already sure that this is a turning point into the construction industry. Timber construction has been considered mature, has been considered reliable, has been considered as a way to solve different problems, not just the carbon problems, but also the de-risking of a project, the procurement side of a project, the durability of a project, and therefore the whole life cycle. So this is like a new start for the construction industry at large. So thanks again to the CEFC and all those who supported their initiative. And I really look forward to see new exciting projects and organizing other meetings and webinars like this. And thank all of you again for being with us today. See you the next time.